In this video, I am going to find the inverse of the function f of x is equal to negative 3x plus 5 over x minus 1, given that x is not equal to 1. To find the inverse of a function, we follow a standard process. First, we set the given function to y and solve for x. To solve for x, what we do here is multiply both sides of this equation by x minus 1. I just want to get rid of the denominator. On the left side, I'm going to get xy minus y by using the distributive property y times x is xy, y times negative 1 is negative y. And on the right hand side, this x minus 1 is going to cancel out. That's going to give me negative 3x plus 5. Remember, we are trying to solve for x, so I'm going to bring all the x terms to the left and move all the y terms to the right. So what I'm going to do, I'm going to add 3x to both sides. If I do that, I get xy. I can actually do one more thing, add y to both sides as well. On the left hand side, I'm going to get xy plus 3x, and then negative y and positive y is going to cancel, and on the right hand side, positive 3x, negative 3x is going to cancel. That's going to give me y plus 5. Now what I'm going to do is factor out x on the left hand side. If I do that, I get y plus 3, because xy plus 3x, if I factor out x from it, I'm going to have y in the first term, and in the second one I'm going to be left with 3. So on the right hand side, I'm going to have y plus 5. Now to solve for x, I need to divide both sides by y plus 3. Now I divide both sides by y plus 3. This and this cancel out on the left, and it gives me x is equal to y plus 5 over y plus 3. Now I switch the x's and y's. That means this y becomes x and x becomes y. So it's going to be y is equal to x plus 5 divided by, this is going to become x plus 3. Now I'm claiming this is my inverse function. Now I label it as f inverse of x is equal to x plus 5 over x plus 3. Now to show that this is in fact the inverse of this given function, I need to do function composition in both directions. I need to do f composed with f inverse of x, and I should get x, and then I should also do f inverse composed with f of x, and I should get x. That means regardless of the direction of the composition, I should always get x. So let's do the first one. By definition, f composed with f inverse of x is equal to f of f inverse of x. Keep in mind, this goes as an input to the function f. Now I know what is my f inverse, which I found right here. It is x plus 5 over x plus 3. Now I need to think of this whole thing, x plus 5 over x plus 3, as a single unit that's going into the function f as an input. So look at here, f is taking x as an input. Whatever is inside the parenthesis, that is going to be the input. What does it do to the input? It multiplies it by negative 3 and adds 5 to it, and to that result it does the following. It takes that result and divides it by input minus 1. Now it's going to do the exact same thing. So basically what I am going to do is this. Every time I see x here, I am going to replace it by x plus 5 divided by x plus 3. Now if I do that, I get the following. Now I kind of need to simplify it. So what I'm going to do, I'm going to multiply this by x plus 3 and divide this by x plus 3. Why am I doing this? So that I get the same denominator, and do the same thing here. multiply this by x plus 3 and divide this by x plus 3. If I do that, I get the following. To save some video time, I just simplified it. I just distributed these numbers and then simplified it. And on the top, look, things cancel out. Negative 15, positive 15 is going to cancel out. Negative 3x plus 5x is going to give me positive 2x. This divided by x plus 3. And in the denominator, negative x, positive x is going to cancel. 5 minus 3 is 2. That's going to be divided by x plus 3. Now this is like dividing two fractions. So it's going to be 2x divided by x plus 3 times x plus 3 divided by 2. Please note, this is going to flip, meaning you're taking the reciprocal. Now this and this cancel out, these two and these two cancel out, so that gives you x. So I just found out that f composed with f inverse of x gives me x. Now I've got to do the same thing but the other way around. Now doing this one, so let's go ahead and do that. It's going to be f inverse composed with f of x. By definition, that is f inverse of f of x. Now I know my f of x, which is just this, so I'm just going to plug it into there. F inverse of negative 3x plus 5 divided by x minus 1. Now once again, you should think this whole thing inside the parenthesis as an input that's going into the function f inverse. Then what does f inverse do to input? It adds 5 to it, so it's going to be input plus 5 divided by input plus 3. It's going to do the exact same thing. If I do that, I get this. Now I need to simplify it exactly the same way as I did that. So I'm not going to write down the whole multiplication thing, but you know that you have to multiply 5 by x minus 1, divide 5 by x minus 1, multiply 3 by x minus 1, divide 3 by x minus 1. Actually, on a second thought, just do it here. X minus 1 divided by x minus 1, x minus 1 divided by x minus 1. Now if you do the simplification, this is what you will get. Now I can simplify it. Things are going to cancel out here. Look, positive 5, negative 5 is going to cancel out. Negative 3x plus 5x is 2x. That divided by x minus 1. Now in the bottom, 3x positive, negative 3x cancel out. 5 minus 3 is 2 divided by x minus 1. Now if you simplify it, you're going to get 2x over x minus 1. And the bottom one, you need to take the reciprocal of it, means flip it, is going to be x minus 1 divided by 2. Now this x minus 1, this x minus 1 cancel, this 2 and 2 cancel. That leaves me with just x. See, if I compose it the other way around, I do get also the same value, x. So it does tell me that this function that I found out is in fact the inverse of the given function. However, one very important thing that we need to keep in mind, let me emphasize that. This new function, by the way, is not defined for x is equal to negative 3. Because if I have x is equal to negative 3, then in the denominator I'm going to have negative 3 plus 3, which is 0. That means it will result in division by 0. So the function will be undefined. So make sure that we put the restriction on this function that says that the function is not defined for x is equal to negative 3. So we want x is not equal to negative 3. So that means x cannot be equal to negative 3. So that's what the restriction on this inverse function. Now let me quickly summarize what I talked about. Oh, by the way, before I do so, I could sketch these two functions, but it's kind of messy to do so here, but it will be reflections of each other about the line y is equal to x. So if you graph this function and if you graph this function on the same coordinates and draw the line y is equal to x, you'll see that the functions actually are reflections of each other about the line y is equal to x. So now let me summarize what I talked about here. To find the inverse of this function, we set the y value to this given function, okay, and then solve for x. We did here, then switch the x's and y's, and we get a new function which is this, and we claim that this is our inverse function, and we label it as f inverse of x as we do here. Then we do the composition in both direction, and we get x by composing in both directions. That shows that the function we found is in fact the inverse of the given function. And then finally, if you graph these two functions and also graph the line y is equal to x, you'll see that these two functions, the graphs of these two functions, are reflections or mirror images of each other about the line y is equal to x. I hope that this discussion was helpful. Thank you very much.